Alright, this lesson video is for students who missed the very first additional mathematics lesson of 2025. In this lesson, we started on chapter 8. Now, chapter 8 is from textbook A. Alright, textbook A. Now, essentially, this topic is on coordinate geometry. Now, in a while, I will be getting you to recall some important prior knowledge about this chapter. Now, but before that, there are other skills that I need you to remember before we go into the topic. So let's move away from coordinate geometry because there is one more topic that I need you to recall, and that is complete the square. Now, can you use some time now to complete the square for these two examples? When you are ready, resume the video to check the answer. Alright, let's go through the answer. Now, for the first question, based on what you have learned in eMath, you should be able to know that the first part of the complete the square method involves a bracket square. Now, within the bracket, there should be an x, and then plus 4 out of 2. Now, the number 4 came from the coefficient of x in front, and because it's positive 4, this is positive 4 as well. Next, minus bracket 4 out of 2 square, and lastly, copy over the negative 17. Now, once you have done your calculation, you should end up at the final answer, x plus 2 whole thing square minus 21. Okay, and that is the completed square form for question 1. Now, moving along, question 2 is very relevant to chapter 8, so I need you to pay close attention to this. To complete the square for this, you will notice that at the end of the expression, the constant term is missing. Just now there was a negative 17. Now there isn't. But does that change the method? It doesn't change. So let's see how we proceed to complete the square. Bracket, square, x, and then minus 8 out of 2 minus bracket 8 out of 2. Don't forget the square. And then, because there wasn't a constant term here, likewise, you also do not put any constant term here. Alright, that is the main difference. Now, once I do the calculation properly, I will end up with x minus 4 square minus 16. And that is the completed square form. Now, with that, we will now go straight into chapter 8. And as mentioned, there are some prior knowledge about coordinate geometry that I need to recall. Alright, let's run through the revision. First, if you are given a point A and a point B, coordinates are x1, y1, x2, y2, please recall that when you find a midpoint, the formula is x1 plus x2 out of 2, comma, y1 plus y2 out of 2. Next, for the gradient, the formula will be y2 minus y1 divided by x2 minus x1. Next, now this particular formula for length of a line segment AB, this will be important. We will be using this later on for today's lesson. The formula you have learned in eMath is bracket square plus bracket square. Within the bracket, x2 minus x1, y2 minus y1. Please be careful about the plus and minus signs. Okay, so I put a star here. I will be referring to this later on. Moving on. Now, let's say I give you two lines, line C and line D, and I draw them out. And I mention that lines C and D, they are perpendicular. Now, what do I know about their gradients? So for perpendicular lines, this was one of the chapters in eMath in Sec 3. Please recall that when you have perpendicular lines, their gradients m1 times m2 must be equals to -1. Now this one you need to recall. Very important for the rest of this chapter. And at the same point, I also want to help you to recall some simple calculations. For example, if M1 is 3 over 2, what is M2 that will give a negative 1 when you multiply them? Now at the back of your mind, when you do the mental sum, you should know that M2 has gradient negative 2/3. Sorry. Negative 2/3. Do notice that the fraction actually flipped. Now let's try 2 more. What if M1 is negative 5? Now because of that, the gradient of M2, or rather M2 is positive 1 out of 5. You have to flip the 5 into 1 over 5. Okay, last one. What if M2 is positive 3 out of 4 for the gradient? Now M1's gradient must be negative 4 out of 3. Alright, so with that, we have revised a few things. First, about midpoint. Second, about gradient. Next, about length. And length will be important for today's lesson, as well as gradient. Now, gradient, we will talk about it very shortly as well. Okay, moving along. There is one more concept that is important for this chapter, but we will not use it today. We will use it for the subsequent lesson, but let's revise it just for the sake of the whole chapter, coordinate geometry. Now, how do we form the equation of a straight line? There are 4 steps. Step 1, write down y equals to mx plus c. Step 2, calculate gradient m. Okay, the value of m, gradient. Now to do this, there are a few ways. First, if the question gave you all the coordinates, you can do a y2 minus y1, x2 minus x1. On the other hand, if the question did not give you all the coordinates, but they told you that this line is perpendicular to some other line, then you can involve the concept of m1 times m2 equals to negative 1. Okay, so it depends on what the question gives you. Number 3, once you have the m value, example, if let's say you found that gradient is 2/3, for example, then your next step will be y equals to mx plus c. And then what you need to do next is to substitute one of the points on the line. Okay, and the question should have given you some information. Substitute one of the points, the x1 and the y1, into the formula to calculate for the value of c. Okay, so eventually you have to find the value of c. Now where is c? c is the constant number at the back. Okay, an example. For example, you calculate. Your c value equals to, example, c is equals to negative 5, for example. Then your final answer will be y equals to mx plus c. Okay, and that completes the equation of a straight line. Now all this up to this point is still revision. With that, we can start chapter 8 properly. Now for chapter 8, the chapter talks about circles. Now circles also have equations. Okay, a circle has an equation. And the equation has a certain format. Okay, it follows a certain format. You will learn about the format in a short while. Follows a certain format. Now, what do I mean by follow a certain format? Let's recall a few things. First, refer to this graph. Do you recall the formula, or rather the equation of this curve? For example, this value here is a 6. This is 0. What is the equation of this curve. Now this one will be, an example will be y equals to x squared plus 6. So this is called an equation of the curve. And likewise, a circle is going to have equation as well. Let me show you an example of a circle. Alright, now what you see on the right hand side is a circle. A circle can also be drawn on the x and y axis. So just now we talked about y equals to x squared plus 6 for the curve that you see on the left. On the right, we are going to learn about the equation of the circle very shortly. Okay, now before we get to that, let me just show you the equation and then I need you to make a guess how I got certain numbers into the equation. Let me start. The equation of this circle is x minus 0 squared plus y minus 0 squared equals 5 squared. Now look at this for a while. Can you suspect where the number 0 from here came from? Where did this 0 come from? And where did the 5 come from? Where did these three numbers come from? 1, 2, and 3. Now, if you are very alert, you will notice that the first 0 came from the x-coordinate of the center of the circle. Next. The second 0 came from the y-coordinate of the center of the circle. And lastly, the number 5. The number 5 came from the radius of the circle. Now, this is the format that I was talking about just now. So let's pen it down. Now, this is not on your paper. Can you please copy it down somewhere? The first 0 came from the x-coordinate of the center of the circle. The second 0 came from the y-coordinate of the center of the circle. And the final number, the 5, came from the radius of the circle. So the question has to give you these three information. It has to give you the x-coordinate of the center, the y-coordinate of the center, and the radius. But of course, not all questions will give you all this information. You are expected to find some of them, which we will see in a short while. Okay, so that is an idea of what the equation of a circle is. So if you understand this, we can now move on to page. Okay, let's skip some pages. Let's go to page 3 first. On page 3, this is the general equation of a circle. The circle, when the center is A, B. Now do take note that A is the x-coordinate, B is the y-coordinate. And if it tells you that let me use a different color, that the radius is r units. This is the radius r. You should be able to write the equation of circle in this particular format. X minus a whole thing square plus y minus b whole thing square equals to r squared. This is known as the standard form of the equation of a circle. Sometimes we also say the general equation. Now with that in mind, let's do the redo example together for example 1. Find the equation of a circle. The center is given. So center is given, radius also given. Now with the format, you will write x and it is a minus. Take note, it is a minus, not a plus. In the brackets are both minus. So x minus 0, the first x coordinate, close bracket square, plus y minus 0 as well, close bracket square, equals to the radius square, so 5 square. Now we can do some calculations because x minus 0 is just x, and when you square it, you have x squared. Same goes for y squared. Now for the 5, if you square it, the value becomes 25. Now this is the equation of the circle. Okay. Next. Now what happens if the center of the circle is no longer 0, 0? It is consisting of positive and negative values. The x is positive, the y is negative, and they give you radius. Now what you need to do is, be careful, for the x value, x minus what you see there, so x minus 2 whole thing squared, plus y, okay, be careful here, because we wanted a minus, so what is y minus a minus 3 from EMath? I repeat, y minus minus 3. Now if you have learned your Sec 1 algebra well, you should know that it is y plus 3. Close the bracket, square, equals to 4 squared. Now, for the algebra on the left, it will be very complicated if we expand, so usually they won't ask you to expand. You can just write x minus 2 square plus y plus 3 whole thing square, but the 4 square you have to press calculator to give us 16. This is the equation of this circle. Okay, very easy, right? Because they gave us center, they gave us radius. Now we come to one problem, part C. Part C, okay, very good. They gave us the center, very good. We have this information. So happily, I will start to write. Okay, question gave me x, because Mr. Wilson said when there's a minus sign, I must do a x minus minus 2, and that becomes x plus 2. And for the y minus 5 squared equals to, hang on, the question did not give me the radius. I am stuck. Alright? The question didn't give me the length of the radius. I do not know this value. How do I find it? Alright? Now let's look at the diagram. This is what it means. The circle has center negative 2, 5. It passes through the origin 0, 0. Let me zoom in. It passes through the origin over here, which is 0, 0. Now, how can we calculate radius? That's the problem. If we can find the length of the radius, the problem is solved. So how do I calculate length of a radius? Now, first, what you must do is use the existing information, draw out the radius. So, I have a center, I have 0, 0, which is on the circumference. I am quite sure that this dotted line is the radius. Now, is there a way for me to calculate the length? Recall the start of the lesson. Is there a formula for length if you are given one point and another point? Right? Don't we know that? Remember, I asked you to highlight this in yellow. Length of a line. There is a formula. Now, let's use that. Now, with that information, I can find the radius already. Let's do that. So, the radius is none other than square root of x2 minus x1 square plus y2 minus y1 square. I am going to call this x1, y1, x2, y2. So if I substitute the values accordingly, I will end up with 0 minus minus 2, that will be 0 plus 2. And then y2 minus y1, so 0 minus 5. Now on the calculator, I am going to press it out and leave your answer in insert form. And I will get a square root 29. Now do not give me decimal value, leave it in insert form. So square root 29. Now once I have this radius, I can now safely put it back into the question mark that I got just now. Alright? And there is a reason why I asked you to leave your answer in the insert form. later on you'll realize that after I perform the square, the cert will disappear. So, let's erase the radius. Replace with the square root 29. Now let's expand the bracket on the right hand side. Only the right hand side, huh? Left hand side don't touch. So x plus 2 square plus y minus 5 square equals to, now what is square root 29? Square. In other words, square root 29 square means square root 29 times square root 29. From certs, you should know that the answer is just 29. So the final answer is this. This is the equation of the circle. Let's do one more example. Find the equation of a circle, okay? Center is given, okay, very good. Center is given. Alamak, they never give us the radius again, but they gave us that it passes through one point. Now let's draw it out. The center that was given here is -4, -3. Okay, be careful, both are negative, huh? And it also passed through this point, the green point, which is 2, 1. So that means that because they didn't give us the radius, let's calculate the length of radius. Equals square root. Okay, this one you can do it by yourself. x2 minus x1 square plus y2 minus y1 square. Pick your x1, y1, x2, y2. Okay, be careful of the negative signs. x2 minus 4. Okay, use the brackets carefully. Plus y1 minus 3 squared. Now you should be able to see that you end up with, okay, press your calculator properly. The first one will give you a 6 square, so 36 plus 16. So in cert form, your radius should be square root 52 units. Okay, and similarly, leave your certs over there first. Oh, I forgot to add in the radius. This is the radius. Okay, we are calculating the length of the radius. It is square root 52 units long. Now with this information, we can now start the last part. Find the equation of the circle with center C. Now we have the radius as well. So it will be x minus 4. That will be x plus 4 squared. Plus y minus 3. So that's y plus 3 squared. Remember about this formula. When they are negative, you must do double negative. So x minus 4, y minus 3. And that's how I got this. Equal to, okay, what's the radius that we have just found? The radius is square root 52. Sorry, square root 52 units. Now open the bracket on the right hand side. The left hand side don't touch. And you will end up with the answer 52. This is the equation of the circle. And we are done with parts A, B, C, and D. Alright, so to consolidate, what we have just done is we have stated the general equation of a circle in this format. X minus A whole thing square, x minus B whole thing square equals to radius square. The A and the B came from the center of the circle, and when there are negative signs, you have to do things like x minus 3. That becomes x plus 3. Okay, so it depends. Be careful on a few things, negative signs, and so on. After that, we did 2 questions, part A and B, where all the information are given, the center as well as the radius all given, and we can happily just calculate. But the problem arises in parts C and D, where they gave us only one information about the center, but they didn't tell us about the radius. So for radius, we actually have to use the length formula to calculate out before we finally substitute into the answer to complete the equation of the circle. Okay? Now with that, we have completed the learning target, set the number 2 learning target. We have found the equation of a circle given the coordinates and center of the circle. Alright, now there is one last bit before I end today's lesson. Okay, I will need you to do the next page on the you do question 1, parts A, B, C and D as homework. Okay, so the parts A, B, C and D as homework. The questions are similar to the we do example. So that's one. Then there is one other thing I must cover before we end the lesson, and that is a recap of some knowledge from eMath. Okay, well, I will just finish this off. So I'm just going to cover page 2 and page 3. Basically, I'm revising some eMath concepts. Now, these are important for the rest of this chapter. Okay, prerequisite knowledge of the parts of a circle. This yellow region from eMath, we know that this is a major sorry, my mistake, not major. Minor segment. Now the shaded region is the major segment. The blue line is known as the major arc of the circle. The red line is known as the minor arc of the circle. Alright? Now this blue line that connects one end of a circle to the other is known as a chord. Now this idea of chord is very important for the next part of this topic. Okay, so remember this word chord. I'm going to come to it in a short while. So chord. Now a chord is mentioned in one of the circle properties that you learned last year during extended curriculum. When you draw a chord, okay, and you draw the perpendicular bisector of the chord, that means this line in blue is going to cut the chord into halves. And when it does so, there will be a right angle that will be formed. Now, what is this right angle all about? It's very important. When there's a right angle, we will know that the blue line and the yellow line are perpendicular. Now, immediately, m1 times m2 equals -1. You must know that. Okay, which is my second point on this page. Because they are perpendicular, it is perpendicular right now. We must know that the blue line and the green color line, let me draw it out, they must be perpendicular, and hence they fulfill the m1 times m2 is -1. Okay, that's one. Finally, there is one other eMath concept that you need to recall. Other than knowing that they are perpendicular, just now I mentioned that I mentioned that the perpendicular bisector cuts the AB into two exact halves. Exactly half. Now, what does that tell us about this particular point here? What is it known as? So on A and B, because this part and this part are equal, this point is known as the midpoint, and there is a formula for midpoint. The formula is bracket x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So in summary, the perpendicular bisector must pass through the midpoint of AB. This is a very important concept. Okay, we will use this for the rest of the lesson next week. Okay, so please take note of the summary page, page 2. So what we have just done for the whole of this video is we have covered pages 1, 2, 3, all the way until up to page 3, and page 4 is the homework. Now with that, I am done with today's lesson. Please ensure that you complete You Do question 1, parts A, B, C, and D before our next lesson. Alright, thank you very much. Let's stop the video.